Alright, this video we're going to try to determine if three sides can actually form a triangle. Now this is not about right triangle or not, right? It's not Pythagorean theorem or anything like that. This is kind of a new idea. It's much more basic. Alright, it basically says that any two sides of a triangle must add to be bigger than the third side. If that's not true, then you literally are incapable, you're unable to create a triangle out of those sides. For example, if you have sides that are 5, 7, and 9 inches long, alright, the question is going to sometimes ask you, can you actually form a triangle? And some people might be tempted to put it into Pythagorean theorem and see if it's a right triangle, but that's not really what the question is asking you. It'll ask you, is this a triangle? Any kind of triangle. Do these sides form a triangle? And what you basically want to do is kind of throw it through three tests. You want to say, all right, 5 plus 7, all right, that is, let's see, 12. Is 12 bigger than 9? It has to be bigger than the third side. And of course, it is. So that works. Now let's test 5 plus 9. That's 14. 14 has to be bigger than the third side. The third side in this case is 7. And that works. Your third test is the last combination of sides. 7 plus 9, that's 16. That has to be bigger than the third side, the other side, which it is. Alright, so this answer is yes, these sides form a triangle. Now, it's not a right triangle, but it's going to be either acute or obtuse, which we'll talk about in a subsequent video. Example 2. Do these sides form a triangle? So let's see, if we have 12, 13, and 25. Alright, so let's throw it through our three tests. We're going to see what the sum of the first two is. That's 25. Is that bigger than 25? Is that bigger than 25? The answer, of course, is no. It's exactly the same, and that's not allowed. So it immediately fails. No, these sides cannot form a triangle. It's impossible. So what that means is if you literally had like an inch or a stick that's like 12 inches long, one that's 13 inches long, and one that's 25 inches long, if those were precisely those distances, those lengths, you are physically unable to create a triangle that meets at each vertex. You can create a triangle that kind of looks like this sometimes, where there's like a little bit of an overlap here, but you won't be able to create a nice triangle that meets all at the same vertex. Alright, great. Let's talk about a little bit a few other things here that I think it's worth mentioning in this video, right? And one of them has to do with if you have a triangle given to you and you know that the lengths are 10 inches, 12 inches, and 15 inches. Alright, first of all, we know that can form a triangle because it passes the Triangle Inequality Theorem tests. But the next question might ask you, put the angles, let's sort of like this, put the angles in order from biggest to smallest. From biggest angle to smallest angle. Alright, and that whole order is going to be determined by the sides, right? There's a nice correlation between sides and the angle that is across from it. 10 corresponds with angle B. A corresponds with 15. Right, so there's a nice correlation there. And the rule is very simple. The biggest angle biggest angle is across from the longest side, and the smallest angle is across from the shortest side. And of course, same goes for the middle. You can fill in the rest. Alright, so if we're asked to find the biggest angle right here, the biggest angle is going to be the angle that's across from the biggest side. The biggest side is 15, so the biggest angle is angle A. The biggest is angle A. The smallest angle is across from the smallest side. The smallest side is segment AC, so the smallest angle is angle B. And the one in the middle, of course, is across from the middle side. All right, that works for that kind of works conversely as well. If you're given angles, then the sides all sort of correspond. I'll show you an example of that. All right, let's name these D, E, and F. Let's say we are given 30 degrees and 105 degrees. All right, and the question's asking you to basically find out what the longest side is, what the shortest side is, and what the middle side is. You're asked to put them in order. Right, based on the picture, you can probably guess the answers, but you know, not every triangle is going to be as simple to guess. So first things first, I think it's probably helpful to figure out, if you're given two angles, you should probably want to figure out the third one. All right, triangle sum theorem, as you remember, tells us that the interior angles of every single triangle add up to 180. So 135, take that away from 180, and you get your third angle. All right, 75 and 105 is 180. That checks out. All right, across from the biggest angle is 105, which means the biggest side is going to be segment FE. The biggest angle and the biggest side, they all correspond. All right, so segment FE is across from the biggest angle, and therefore it is the longest side. The smallest angle, which is 30, is going to be across from the shortest side. The shortest side is segment DE. When we write segments, we put the line segment above it. And of course, the middle angle, 45 degrees, is across from segment DF, which is the middle side. Great. And one more thing I'll mention here while we're talking about triangle inequality stuff is sometimes you'll be asked, what number am I on? Number 5, I think? Yeah, number 5. Sometimes you'll be asked a question about the potential range. What is the range of potential third side? What is the range of a potential third side? And to figure that out, right, all you're really kind of doing is using these same ideas. So if I give you one side is 9 centimeters and one is 20 centimeters, you need to come up with a range of the potential third side, right? And there are an infinite number of answers, but if we kind of think about our third side and call it x, right? If we kind of guess a few, let's guess and check a few. If x is, I'll put it over here, can x equal 10? Well, let's see. 9 and 10 is 19. That has to be bigger than the third side. So that's not right. 10 can't work because 9 plus 10 is 19, and that's not bigger than the third side. So we'll erase that. How about 30. Can x equal 30? 9 plus 30 is 39. That's bigger than 20. That's good. 9 plus 20 is 29. We'll add these two together. 29 has to be bigger than 30. It isn't. Alright, so that's not right. Can't have that. So we can go on like this all day, guessing the potential sides. Or what you can do is do like a little shortcut, right? Take 9 and 20, add them together. We know that the third side has to be less than 29. It can't be equal to, so don't put that there. It has to be less than 29. And the other trick is to subtract them. 20 minus 9 is 11. X has to be bigger than 11. So there's your range right there. X must be in between 11 and 29. Alright, and you can kind of guess. You can plug some stuff in there, like 12 will work, 28 will work, 28.777 will work. Anything that's infinitely close to 29, less than it, but infinitely close to it will work. Anything that's infinitely close to 11, but greater than it will work. Anything that's in between these two numbers, and this is a compound inequality. That's usually how we write it. Alright, hope those 5 examples helped you.